Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 4 of lesson number 10, Gravitation, which was put forth by Sir Isaac Newton. Now Newton was the one who has given us the concept of gravitational force, because of which many other concepts have been clear and many other facts about gravity has been known, right? So we have already discussed on the basic information with respect to gravitation, what exactly it is, and we have even discussed on different examples with respect to it. Like if you throw anything up in upward, what will happen? That object is going to come down, right? Again, after reaching a certain height, it will again come down. Why is it so? Why anything that you're throwing high up, like upward, is not going towards sky? After reaching a certain height, it falls down again. So the reason behind that is the gravitational force, right? So we have already discussed on basic information and even about Sir Isaac Newton, how he came across the idea of gravitation. Like he was sitting under a apple tree and suddenly what happened is an apple fell off on his head. So through that he, one thought came to his mind, that why not the apple is going high up in the sky? Why always all the fruits they fall down? So eventually, while he did his research and studies further, he came across one new type of force which we now know it as gravitational force, right? So before him, like many other scientists, they were knowing the fact, but they were not exactly able to explain the concept of gravitation, whereas Newton came up with different examples, like the sun is in the center and all the planets, they keep on revolving around it. That is also even possible because of gravitation, right? So various different examples were made clear by Newton, and that is why whenever it comes to gravitation, Newton has been known. Because if you even know the SI unit for forces, Newton itself, that we represent as capital N. So he has done many other research work as well that we have even discussed on, right? So before I proceed with the further part, like with this part and with this part of the lesson, gravitation, I want each one of you to please revise whatever notes you have taken back in part 3, and then we'll do a small revision of all the slides and I'll proceed with the next part for today. I hope every one of you have started revising everything. Like if you remember, starting from part 1 was the introduction to gravitation, where I have made you aware of many basic concepts that you need to know before I start the lesson, right? So you all might have taken notes on that. So please revise, start whatever you have taken note of starting from part 1. So we have started the lesson gravitation by discussing on the basic like concepts on gravitation, right? The explanation on gravitation has been given. So I just want you all to please go through this slide. I hope every one of you are revising it. Now whatever question mark you can see on the screen, you need to try to answer them now, because like you are revising it for the second to third time now, right? So make sure you know the answers and like it is becoming self-explanatory to you as well. After this, we discussed on this activity 10.1. So I want each one of you to please go through this slide as well. You should be knowing like how to write the observation, inference, explanation, everything for this. After this, we discussed on the universal law of gravitation. So I want each one of you to please go through it quickly as well. I hope you all are going through it properly. You need to go through it properly because this one is very important. Okay. So over here we have like the derivation of the formula F is equal to G, then capital M small m upon D square, right? So this is the formula that we came up with. I want each one of you to please go through it quickly. I hope every one of you are going through it. Like you need to even go through the value of the g that has been given. That is gravitational constant, right? And the value of g is 6.673 into 10 raised to minus 11 Newton meter square per kg square. After this, we discussed on Sir Isaac Newton, who exactly he was, and like what are the different achievements that he had in his life, right? So I want each one of you to please go through this slide. I hope every one of you are going through it. So here we have like more, you can say, discoveries of Newton and what he was exactly working on. Everything has been given over here. I want you all to please go through this slide as well properly. After this, here we have an example 10.1 where we saw how we can calculate force, right, that is exerted by the earth on the moon. So I just want you all to go through it quickly. I hope you all are going through it. Then we discussed on the importance of universal law of gravitation, which are been given over here. So I want each one of you to please go through this slide as well, as you can get this question as well for 2 marks. After this, like after discussing on the importance of the universal law of gravitation, we discussed on free fall, and for that we had an activity, and the description has been given on the next slide, right? So I just want you all to please go through this activity that has been given with respect to free fall over here. So over here we have like a brief explanation on free fall that has been given, right? So I just want you all to please go through this slide. Then after this free fall, like we have the formula like about the acceleration due to gravity that has been given over here, right? That g is equal to, now small g, we know that as acceleration due to gravity. Capital G is the universal constant that we have, right? So how we can derive the formula for acceleration due to gravity is small g is equal to capital G, then small m is mass upon r square is radius square. Okay. I hope every one of you are going through it. Like this is the formula that we have derived for acceleration due to gravity, right? So like you can get this type of questions, and like you will be getting different examples where you will have to apply the formula and like solve the question as well. Okay. Then now we need to discuss how can we calculate the value of g. Now you know g is, small g is acceleration due to gravity, right? So how can we calculate the value of the small g is using the formula that we have, that is g is equal to capital G, then m, that is mass, upon r square, that is radius square. Okay, so to calculate the value of g, we should put the values of capital G. We know that that is constant. What is the value of capital G? 6.7 into 10 raised to minus 11, right? So we'll put the value of the capital G, then m if it is given, and r in the equation 10.9 that we have. So equation 10.9 is small g is equal to capital G capital M upon r square, right? So we need to insert the values of them. So g is equal to 6.7 into 10 raised to minus 11 Newton meter square kg square. Then mass of the earth, we know that mass is 6 into 10 raised to 24 kg. And when it comes to the radius of the earth, radius of earth is 6.4 into 10 raised to 6 meters. Okay, so now we have the values, like we have the value of capital G, capital M, capital R, right? So we are going to like put that values, and we are going to calculate the thing. So after calculating the value of this acceleration due to gravity, we get the answer as 9.8 meter per second square. So always the value of acceleration due to gravity, we consider that as 9.8 meter per second square. Okay. So I want each one of you to please write this in your book. I hope every one of you are writing it. After this, now see, we have like once you complete writing this, we will be discussing on motion of objects under the influence of gravitational force of earth. But before that, I want you all to be clear with the term that have been given. I hope every one of you are writing it. After this, we have like the next topic as motion of objects under the influence of gravitational force of earth. Now as you can see the objects, and like it's going to be towards downwards, as like you can see acceleration due to gravity, that is small g, that has been given, right? So let us do an activity to understand whether all objects, hollow or solid, big or small, will fall from a height at the same rate. What do you think for this? Will it fall down at the same rate? So see, we know that an object experiences acceleration during free fall, right? Whenever there is going to be a free fall, the object is going to experience acceleration in that case, right? So from equation 10.9, now equation 10.9 is this one. G is equal to, that is acceleration due to gravity, is equal to gravitational constant mass upon radius square, right? So from this equation, the acceleration experienced by an object is independent of its mass. It's not dependent on anyone. It's independent of its mass, right? So this means that all objects, whether they are hollow or solid, big or small, they should fall at the same time, right? If you're throwing anything up, high up in the sky, or like upward, they should fall down at the same rate, right? So according to a story, Galileo dropped different objects from the top of the Leaning Tower of Pisa in Italy to prove the same. So what he did, he had like many different objects together, and he kept on throwing all the objects from this Leaning Tower of Pisa in Italy. And as the acceleration due to gravity is constant near the earth, all the equations of for the uniformly accelerated motion of the objects, they become valid with acceleration A that has been replaced by G, right? So we have already studied these three equations in the last lesson, right? So we have the equation as V is equal to U plus AT. Then we have another equation as S is equal to ut plus half at square, and one more equation that we had was v square is equal to u square plus 2as. These are the three important equations that we have, right? So here u and v are the initial and the final velocity. So u is the initial velocity, v is the final velocity, and s is the distance covered in time that is being represented by t. So s is the distance, u is the initial velocity, v is the final velocity, t is time, a is acceleration. Okay, so in applying these equations, we will take acceleration to be positive when it is in the direction of the velocity, that is in the direction of motion. So whenever we find out that acceleration is in the direction of its velocity, in that case we will consider it to be positive. But if if it is opposite in direction, in that case it will be negative. So acceleration a will be taken as negative when it opposes the motion. Okay, so a will be positive if it's in the direction of velocity, and it will be negative if it's in direction of, like if it opposes the direction. Okay, I hope every one of you have started writing all the important points from screen. I hope every one of you are writing it. Now after this, we have this example 10.2, which I will be starting that in the next part. We will not do it today, but make sure that whatever we discussed under this, like motion of object under the influence of gravitational force of earth and how to calculate the value of g, you are clear with it, so that like while we solve the example and we study about it, you are aware of the concept. Okay. So we'll discuss on this activity 10.2 in the next class. After that, we have like one more example to discuss. We'll be discussing on that as well. Then we have mass and weight to discuss. So whenever it comes to gravitation, weight and mass like are very common. So we'll be discussing on weight and mass in detail as well. Then we'll discuss on weight of an object on the moon. Like if you go and land on moon, what will be your weight? We'll be discussing on that as well in detail. Okay. Then after that, we again have an example where we will be discussing on how to calculate the weight on earth. We'll be doing that. Then we will discuss on thrust and pressure. Now thrust and pressure, they are also equally important, so make sure every one of you are aware of it as well. So we'll discuss on thrust and pressure in detail. Then after that, after discussing about thrust and pressure in detail, like we will be discussing on the formula for calculating that. After that, after discussing on it, we will be even discussing on example 10.6 in detail. Okay, along with the solution, like the solution has been provided to us, we'll be discussing on that. Then after this, we will be discussing on pressure in fluids. What kind of pressure has been exerted on fluids, we'll be discussing on that as well. And then we have buoyancy to discuss, which is again a very important topic. So make sure whenever I teach you all, you are like knowing, understanding the concept properly, because that is what is very important, right? Then after this buoyancy, we'll discuss on this activity 10.4 in detail. Then after this activity, we have like why objects float or sink when placed on the surface of water. We'll be discussing on that. Then we have activity 10.6, again we'll be discussing on that as well. And then a last important question that we have, that is Archimedes principle. So we'll discuss on that as well, like what exactly Archimedes principle is in detail. Okay. Then after that, we have relative density to discuss again. So we'll be like even discussing on the formula of relative density, what exactly it is. Then we have an example 10.7 to discuss. So we'll be doing this as well. And then we have the summary question to discuss. We will be doing that as well. Okay. Then after this, we have some exercise questions. So I'm showing you the slides one by one. I want each one of you to please go through the questions that have been given on screen. I hope every one of you are going through the questions. So we have altogether 22 questions to discuss. So make sure you are like knowing what type of questions have been given over here, so that when we discuss, you are well aware of them. So this is the last question that we will be discussing for the lesson gravitation, and this is how we will be ending up with the lesson gravitation. Okay, so make sure whatever we have discussed in this part you all are revising each and everything. So I will be continuing with the rest of the part for the lesson in the next part. Like, as you all know what are the parts that we are left with, right? So we'll be continuing that in the next part. Make sure you're revising each and every thing, so that it becomes easier for you to understand and write the answers in your own words. So I'll end this part over here and I'll continue the further part for the lesson gravitation in the next part. Thank you everyone.